Hey everybody, this is Leon here, and we are going to be talking about Graphics Workstation hardware. And so we're just going to be covering the hardware, some basic requirements for the hardware for a Graphics Workstation, and we might at the end cover some pieces of software, and then look at how much they're going to need in terms of hardware-wise. So what sorts of amounts of RAM they're going to need. CPUs, GPUs, I say CPUs and GPUs, so you're going to have multiple. Probably going to only have one. But, you know, CPUs, GPUs, storage, and things like that. So, as I said, we're going to be covering the hardware first, and we might do some software after. So, we're going to get onto the CPU. I have a nice picture of a Ryzen from AMD. It's a Ryzen 5. Oh yeah, it says AMD Ryzen 5 3600. Anyway, the CPU is going to be an important part of your build, especially since it's going to be doing all the calculations for every pixel that you edit. And when I say all the calculations, I mean every single calculation. You may think, oh, I thought the GPU was going to do that. Sorry about the sound outside, but you may think, oh, I thought the GPU would do the graphics processing here. And while that is true for things like compute shaders and other forms of shaders, not just compute shaders, that is true. Some programs do use the GPU to do these calculations. However, normally it's going to be using the CPU when you do a certain edit. Normally, the only times I've ever really seen GPU be involved in that sort of process is when you're adding things like filters. Because they're going to be more based off of, you may or may not know what I'm on about here, you might want to search it, you might not, but they'll be more based off of vertex shaders, pixel shaders, and I believe the last one's object shaders. I can't quite remember. More shaders in a bit. But they do this, they do this, so you may encounter programs, I believe Photoshop does this, just to speed up the process. If you have a GPU, but normally it's going to be the CPU doing all these calculations itself, and this is going to be affected by the CPU's clock speed and the amount of cores and even hyperthreads that a CPU has. So let me quickly explain what all these terms mean. So you have the clock speed. The clock speed is the speed at which calculations are computed in the CPU. So most modern CPUs at the moment are 3.6 gigahertz or 3.8 gigahertz. So that gigahertz is referring to billion. The giga in that is billion, and then hertz would be a frequency. So 3.6 is going to be 3,600,000,000 3,600,000,000 calculations per second per core. So you can see CPUs run pretty fast. We can't do that as people, but we have a lot of trade-offs that computers can't do as well, so it's always fun. But that's a lot of calculations per second, and this is where we are at the moment. You can get CPUs which have turbo speeds if you want to ever overclock it in the future, so you have it for a little longer. I'll put more stress on the CPU, so I don't recommend doing it just as you buy the CPU if you're buying an older one. But I'll recommend building using the most modern parts you can, latest generation, especially for things like a workstation which you want to work for years. You're going to want a CPU that's going to last. So I would recommend a 3.8 gigahertz, just because they are the thing which is coming in at the moment. It's not speeding up as quickly as it was before, and that's mainly because some of the more sciencey stuff to do with how CPUs work. And certain quantum mechanics getting in the way, but that's for another episode completely. But recommend 3.8 gigahertz, 4 gigahertz if you can find one. Make sure you're buying from a trusted seller, obviously, because people are gonna lie. They do it with every product, and always read up on the thing that you're buying. So what are cores? Cores are going to be so you have your CPU can perform all these calculations per second, and you have cores in that CPU. So imagine like CPUs inside your CPU. These are the different places where the calculations will happen. So if you have 4 cores, you can have 4 calculations happening at the same time, and if it's a 3 gigahertz CPU, you'd have 3 billion calculations happening at the same time on 4 different cores. That's a lot of calculations. So with the 3.8 gigahertz CPU, nowadays you can buy octa-core being 8 cores. You can find these pretty readily. They are a bit more expensive because they're more premium, but for a workstation, they're well worth the money, especially if you're a professional graphics designer. So there's another thing to do with cores called hyperthreading, and what hyperthreading is you can imagine it doesn't work like this in the real world. This is not how it works, but the best way to imagine this is, imagine you have your core, and your core is like a lane on a highway, or motorway. I'll probably end up saying motorway because UK, but you have your motorway. What you do is you split that motorway into two different lanes. So where you have this massive lane which you split into 2, they can't compute as much, not as much traffic can go through it. Normally you could have 2 cars, say, going through the 1 lane, but now you can only have 2 cars going through 2 separate lanes at the same time, so 1 car each lane. It is half the amount of cars, but you have 2 different things happening at the same time. So 1 lane can turn off while the other one still goes straight, if you imagine it like that. So if you had a I'm going to say 2 gigahertz just to make the math simpler for you to understand. But if you had and simpler for me to do on video, but if you had a 2 gigahertz CPU and you had 4 cores with 4 hyperthreads, it's like having 8 cores, but you're running each of those threads at 1 gigahertz instead of 2. So be sure to look out for this. The amazing thing with cores is it allows for you to have much more flexibility in the multitasking department. So if you're running a program like Photoshop, it can use multiple cores to calculate the different pixel values, so it doesn't have to do each one individually. It can be doing 4 at a time. And then you may have another thread dedicated to running a piece of software which has your reference images open, as per se, things like Chrome in the Images tab, things like that. Or just the images, the gallery piece of software that you have on your computer. So the CPU is very important, so try to look out for these different things when buying a CPU. The next thing that we're going to be talking about, here we have a nice picture of a GeForce GTX. I'm not sure what one. I think it's a 1050. Sorry, and it's going to be the GPU. And the GPU is also very important. Just because I said that the CPU does a lot of the calculations itself, it is also heavy on the GPU for a graphics workstation. And this is because your graphics workstation, when you're editing your image, say in Photoshop, I'm going to use Photoshop as the example for most of these. If you're editing your picture in Photoshop, then your GPU has to display all of this to the screen. And also some calculations might be done by the GPU because it's quicker to do the graphics calculations on the GPU, as I was saying before with shaders. So you never know how the program's going to use these, but having the ability to have these options available can really help speed up your development. And you also want to be able to view your image in real time as you're editing it, because if it's not in real time, it can really affect how you edit your image. You may end up getting frustrated with it and leaving it at a different part to what you wanted it to be, or doing a different sort of effect because the other one was taking too long to compute. You want it to be happening in real time, because if you don't see those changes as you're doing them, things can happen that you don't want to happen, and it can ruin the whole project. So having a decent GPU is always good. Try and get a higher end one. The 2080s are out now, well worth the money for a workstation. In the AMD department, they have the Vega 56. These are well worth it as well for workstations. They're aimed for people with workstations as well. And just having a GPU, especially with rendering your program after, your GPU does all of that rendering, exporting, things like that. Your GPU is made for these sorts of things. So having a GPU is very important. there is an amount of RAM on the GPU. You may have heard it. It will say 8 GB of VRAM. VRAM, normally when we mention VRAM, we mean virtual RAM, and that's where the RAM sticks on your machine, get full up, and it starts using your hard drives or your SSD cards with a little bit of memory in those allocated as VRAM, virtual RAM. So it's not quite the same thing with a GPU, but it also has VRAM on board. Try and go for one with 8 GB or above, because you never know how much data you're going to have stored on that GPU, because it does have data stored temporarily, like the shader graphics and the calculations for all of those, and the results and the information that's being passed through. It will buffer all of these sorts of things, and your GPU is going to have to be able to do these sorts of things. So having a good GPU is very important. Alright, the next thing we're going to be going on to is RAM. RAM is another very important aspect of your machine as well, because RAM is really one of the most important things when it comes to your graphics workstation. Without this, there's no point buying the rest of your components. If you're going to want RAM that's fast enough, 3000s range is great. Try and go for 3400s. If you can't, then lower down on 2800s. They're good. Try and aim high. Good quality. You can get Corsair ones pretty cheap for the price at the moment in 2019. And this has been recorded on the 11th. So try. They're cheap at the moment. So try to get good RAM. Also, when selecting your RAM, you're gonna want 16 gigs, especially for a workstation. And this is because it's going to be displaying images, you're going to be editing images, all those pixels that are in your image, if you're working with bitmaps, I mean in this case, all your pixels in that image are going to be stored in a RAM while you're editing them, or a big chunk of it will at least. So, especially when you're editing things like 4K images, these are going to be much more intensive on your RAM, because you're going to need a lot more space. When you're buying RAM as well, if your motherboard has 2 slots, then you're going for 16 gigs. Go for 2 8 gig sticks, because having it split over multiples faster, and you can imagine that same thing which we spoke about with the CPU, that highway. It's like having multiple routes to go to. It's much quicker than if you're using one massive jam. You have 2 separate lines. It can still jam, but they're gonna have 2 different places to go to, and everybody's going to be split up nicely. If you want to imagine it like this. So try and split it over as many as possible. If you have 4 stick spaces instead of 2, go for 4 4s. It's going to be much faster. You may pay that little extra for the premium, but it's still well worth the money, especially since you're going to be editing things a lot of the time, and you're going to need the space for it. For one, having that much space is amazing, because it also gives you a little extra playroom if you want to have another image open and editing, you know. And then it also gives you that extra speed as well, which is always nice to have. So